Good morning, everybody. I apologize for not being at school today, but I wanted to make sure that we got all the notes for 1.7 so that you're ready for your test on Friday. Would you please make sure to have your proof reasons sheet out with you? I know we've done a couple of these examples together, but I just wanted to refresh that with you and finish the notes so that you have them for completing that worksheet. So remember, when we state the reason, it's just like the why for the statement is true. For the first example, we said if the measure of angle 1 equals 90, then angle 1 is a right angle. How do we know that's true? Because that's how we've defined it. So yesterday you should have written definition of right angle on your note packet. If x plus 8 equals 14, then x would equal 6. Well, how do we go from the if to the then? We talked about this yesterday as well. If you move the 8 over by subtracting, we know that we would get x equals 6. And that rule is possible because of the subtraction property of equality. Oopsie, there we go, subtraction property. And then you can write the word of equality or just write that equal symbol. I'm fine either way on that. Another type of property that we applied yesterday, it says if 9n equals 18, then n equals 2. So how did we get n by itself? If you remember, we divided each side by 9, and 18 divided by 9 is 2. That would be the division property. All right, please turn it over. Example 2 had us completing everything from the statement side to the reason side. And remember, we always have an original statement, and if we're asked to give a reason for that, it's always given, which is kind of nice. And then we had two subtraction properties to move things to each side of the equation, and we ended with that division property of equality. Now, down below, we're going to transition into some geometry type statements and reasons. For example 3, it says use the statement and diagram to determine the reason. Statement for number 1, if AB is perpendicular to EF, then the measure of angle A is 90 degrees. If I look at the picture, AB runs top to bottom, and then EF goes left to right straight across. If they're perpendicular, remember they form that right angle in the corner, then angle 1 equals 90 degrees. Okay, so that makes sense. How do we know that's true though? How did we learn that perpendicular lines form right angles? Anytime I ask you how we learn something or how we know it's true, it's because of the definition. The reason then, it's not definition of right angle because right angle isn't listed in the statement, but the word perpendicular is. So we know based on that and the definition of perpendicular lines, that perpendicular lines form right angles, which do then equal 90 degrees. So definition of perpendicular, there's a D right there, and then lines. That's how we know that that angle would equal 90 degrees. The second sentence looks pretty similar. Statement 2, if CD is perpendicular to EF, then angle 2, the measure of angle 2 is 90 degrees as well. Now CD is over here on the right, and it's perpendicular to the same segment EF. And we know that this would be true as well for the exact same reason as statement 1. Again, because of definition of perpendicular lines. As we look at that picture, it says the measure of angle 1 equals 90 degrees. So we've got that right angle labeled on the picture, and angle 2 equals 90 degrees. Then the measure of angle 1 would equal the measure of angle 2. So let's think about, out of all the reasons we had on our reason sheet, if the measure of angle 1 equals 90 and the measure of angle 2 equals 90, then angle 1 should equal 2. So technically there are three things happening here. We've got a 90-degree measure and then angle 1 and angle 2. So we're comparing three parts. And when we eliminate one of those parts, like that 90, and we just put angle 1 equal to angle 2, that's that RST 1, 2, 3 rule. And if we have three parts, that's going to be the transitive property. It allows you to create a new statement given the other two. And then statement 4, if the measure of angle 1 equals the measure of angle 2, then angle 1 is congruent to angle 2. Notice here we got rid of the m's and we made the equal sign a congruent sign. If you look at your formula sheet on the back, there's a definition that allows us to do that. It's kind of weird, but it works for us. Did you find it? It's the definition of congruent angles. And that works to go from equal to congruent or congruent back to equals. Works in either order. Okay, last one down below. For our final example in the notes, complete the reasons for each statement. So again, I've given you a statement column. We're going to provide the reasons in the reason column. It says the measure of angle QPR is equal to the measure of angle RPS. That's what we're starting with. So that's the given statement. On the picture, if I look at Q down to P over to R, that's this kind of smaller angle on top. And then RPS, that's the angle, the smaller angle on the bottom. It says that those two angles are equal to each other. Okay, fair enough. In the next statement, the measure of angle QPR plus RPS equals QPS. So notice that this is a small angle plus another small angle, but QPS is the big angle. Where have we seen that on our reason sheet? That's going to be on the front, and that's one of the first things we talked about. If you can add two smaller angles to equal a bigger angle, that's literally just angle addition. That's what allows us to write that statement. But then check out what happens in the next row. It looks very similar, but instead of the measure of angle RPS, they plugged in QPR in its place. So in statement 1, it said QPR was equal to RPS, so how can we plug something in for something else? That's also one of our reasons. That was the substitution property. When you plug something in for something else because they're equal, that's called substitution. Like so. Now this last step is going to be a little tricky. It actually isn't one of the things on our reason sheet, but we might want to add it on. It says, so from row 3 to row 4, the measure of QPR plus the measure of QPR. So notice what they did in row 4 is they put 2 out in front. So it's kind of like they added these together to get 2 of them. If they add them together, that's not the addition property of equality though, because we're not adding QPR to both sides. If you literally add the two things together to simplify the left-hand side, what we did was combine like terms. And that's an actual reason option. So, whoa, sorry, I'm thinking while I'm writing. Here we go. We're going to combine like terms. So you may want to add this to the bottom of your reason sheet on either the first page or the second page, doesn't matter. Just to show that if you're just simplifying one side by putting things together and not moving it to the other side, this would be the reason why. All right, everybody, those are the notes for 1-7. Please complete your 1-7 Day 1 worksheet.